Hi everyone, my name is Xianghao. I'm from Video Compliance and Clarification team in Amazon Prime Video. Today I will give a presentation on intro and recap detection for movies and TV series. This is joint work with Kripa, Ben, Vernon, and Rafi. Modern video streaming services offer millions of video titles for its customers. A lot of these titles have repetitive intro and recap content that customers have to manually skip in order to achieve an uninterrupted viewing experience. To avoid this unnecessary friction, some services including Prime Video and Netflix have added skip intro and skip recap feature. To efficiently scale this experience for the entire catalog, it's important to automate the process of finding the intro and recap parts of titles. There are several learning-based approaches that could be applied to tackle this detection problem. On the unsupervised end of the spectrum, one could use content-based matching to find intro and recap as repeating content. This approach does not require label data but requires availability of multiple episodes before the content in different episodes can be matched. Also, this approach does not work well for titles where the intro content changes in different episodes. An alternative way is the supervised approach, which requires label data and assumes there are frequently occurring patterns between the video content and the intro recap labels. But this approach is applicable to intro, recap, and other types of video segments like end credit, where the unsupervised model are not readily applicable. The fact that humans can differentiate those different of content suggests that there are discernible intro and recap patterns in the title. For intros, as example, the title credit information are usually displayed on a black background, such as the actor and director's information, and there are usually a few seconds of silent transition period right after credit. For recap, usually a series of rapidly changing scenes are shown in the title, and many recaps start with an opening sentence such as "previously on," along with music playing in the background. Particularly for cloud-based service, since it's not practical to access the client's entire video catalog, it's very important to use supervised models that can find intro and recap in each video uploaded by the customer without requiring any additional dependencies. We therefore focus this work on supervised approach. There are several key challenges to build a supervised model. First, it's unclear how to best formulating the intro and recap detection into the supervised learning problem. For instance, the problem could be formulated as a regression problem, but is likely to give a suboptimal result since the transition among intro, recap, and actual content would not be explicitly modeled. Second, while there are many intro and recap patterns, it's unclear what's the best way to characterize those patterns in the model. Third, the different patterns exist in different data modalities, and it's unclear how to optimally use multiple data modalities. To solve this challenge, we framed intro and recap detection as a sequence labeling problem as demonstrated in the figure. The input for our problem is a time series of video intervals, and the goal is to label each time interval with one of the three possible labels: intro, recap, and actual content. Our proposed architecture consists of following three main components. First, it uses CNN to extract descriptive visual and audio features from the video title. These features are fed into bidirectional LSTMs to capture the various long and short-term dependencies among different frame features. Finally, for optimal temporal smoothing, we use conditional random field to jointly optimize the label of all video frames. To measure our model performance, we use precision recall, where the true positive defined as detections where both the start and end timestamp are within T seconds from the ground truth. We compare our model's results showing inside the red box with three other approaches using visual feature. These three other alternative approaches frame the intro and recap detection as the temporal action localization problem. We can see that our proposed method has significantly better performance since our proposed method captures the long and short-term dependencies and models the temporal transition of the boundary of intro and recap more explicitly. In this slide, we show the performance of our proposed architecture using different types of features, namely audio, video, early fusion, and late fusion of audio and visual features. We can see that early fusion results in better model performance among all four types. This indicates that our architecture has the capacity to model both the visual and audio feature very well when they are fed together into the model. In this work, we presented an end-to-end approach for intro and recap detection and achieve high accuracy. Going forward, we plan to experiment other ways of feature fusion and incorporate caption into our model.